our next challenge is entitled An Introduction to the MapReduce Pattern. You will be implementing a basic case of the MapReduce pattern in programming. Given a vector stored as an array of numbers, find the magnitude of the vector. Use the standard distance formula for n-dimensional Cartesian coordinates. So they have some examples here. If you're familiar with vectors, this may be immediately accessible to you. If not, you may have to look something up. I did a quick Google search here. You can get an idea of the magnitude. There are going to be many sites that will tell you this, but you can imagine each value we get in our array will correspond to one of these values inside the parentheses here. So we'll have, an x, a y, a z, possibly other values as well. They said the arrays could be any size. But essentially, whatever value we get in our array, we're going to square it and add all those squares up, and then we'll take the square root of it. And you can think of this like Pythagorean's theorem, right? A squared plus b squared equals c squared, right? This would be the hypotenuse. You could imagine a line coming out here, a vertical line here, and if you square both of those values, that's going to be equal to this distance squared. So you take the square root to get this didn't know I can move that. To get the distance here, this would be c. So yeah, feel free to read up all you like about that. So back here, feel free to test these out. 3 squared is 9, plus 4 squared is 16, 9 plus 16 is 25. If you take the square root of 25, you're left with 5. 0 squared is 0, 0 squared is 0, negative 10 squared is 100. Take the square root of 100 and you get 10. It's good they do the edge case here with an empty array. They just want 0. And yeah, feel free to add these up and take the square root if you'd like. Notes: the array can have any length. The input array will contain integers, except for the empty array, which should return 0. And then it says write own map and reduce methods in your solution, or use these query through link. Don't forget to connect the library system link. I'm going to opt for the latter. I'm going to use link methods for mine. So we can head over to code. Please pause and give this an honest attempt and resume when you're ready. So, like I said, I'm going to bring in link. I'm going to use some link methods that already exist. And some of them, I think all of them we've used before. So in a way, this will be a very good refresher. So I think the first part of this problem is to square all of the values in the array. Remember, we're going to add up all of the squares, and then we're going to take the square root of it to get our answer for the magnitude. So we have a link method that can do something like this. We know array, this int array, implements the IEnumerable interface, so it's enumerable. And because of that, we have a select method, right? And select projects each element of a sequence into a new form. It's a nice general way to describe it. And what new form do we want for our values? We want them to be squared, right? So let's put in a lambda method that will square these. I'll use n to represent each integer that gets processed here in the select method. Oops. And we're going to simply do n by n, right? And that'll give us the squares. This will go over each integer value in the array, and it will square them. And it'll put them in a new collection that'll have all of the squares. Okay, great. So we have the sum of the squares at this point. What can we do next? Next, we want to add them all up. You may remember a link method we've used in the past to do this, and it was called aggregate. And you can check the docs if you don't remember it. Applies an accumulator function over a sequence. We're going to use it for addition. You don't have to use it that way, but that's a common use case. And this will probably look familiar when you see the example. Remember this? We're going to do something like this. We're going to give it that initial value, the seed as they call it. We're going to start with 0 as well. Then we give it two parameters. One's a running total, and one represents an element from the collection, this ints array. And then you can tell it however you want to handle those. And so let's get on with that and tailor this for our case. So, and notice how we're chaining here, right? We know this bit right here is going to give us another enumerable collection. So now we're calling aggregate on it. And we can, it's enumerable. So we're going to give it, let's give it that 0 seed value we want to add up from 0. Then we're going to give it two parameters. I thought their total was appropriately named. Let's use that. And then I'm going to use n for just an integer coming from this collection of squares here. And then how do we want to process this, right? What are we going to do? They're already squared. So we could say total plus equals n, right? It starts at 0. Just keep adding each number that you encounter in this collection of squares. Just keep adding them up. Cool. So now that we have that, we have a sum of squares. And I think alternatively you could just call aggregate on this without the squaring here, and that might be a little better. We could try it that way too, where at this total part, instead of adding just n, we could say add n times n. And so that would probably be better than going through the collection twice. You know what, let's do that. Let's try it that way. So we're going to add these up. Imagine now that we're just doing the square in here. Instead of adding n now, each element that we're processing, each of these n's, it's going to represent an integer from this array. Instead of adding that value, let's add the square of that value, n by n. And that way we only have to go over the collection once instead of twice like I had originally done with the select statement. But it was good to see the select statement. You know, that's one definitely to keep in mind. But I think this is a little better. So we can say this. At this point now we have a collection that is a sum of squares, right? And what did we have to do to get the magnitude? We had to take the square root of that entire value. So we've done this before. We know there's a method for that, math square root. And we take the square root of that whole thing. And then we certainly have to return something, right? Because it's expecting a double. Math square root should return a double. And I think I need the system namespace to use the math class here. So let's see, that started 0 total, add the square, take the square root of the whole thing. I think this might do it for us. Let's try it. Bam, there we go, we got it. So yeah, something that seemed maybe a little more complicated than, you know, a quick one line of code here actually worked out pretty nice. I think it's pretty readable. Hopefully you do too, now that you've seen more lambdas and hopefully using them yourself. Yeah, I mean, I think this reads very well like the square root of a sum of squares. Yeah. There are certainly other ways you could have gone about this though, and that's fine too. I like to see your solutions, so feel free to share those. Otherwise, yeah, you know where to find me if you have questions. Otherwise, let's keep moving to the next challenge. Thanks.